Hello, my name is Richard Anthony Marca, and this is my EGR402 Sprint 3 review for my capstone project. The first thing we are going to do is the sprint retrospective, which is looking at JIRA. And this is our burn down chart for our third sprint. As you can see, it is not as low as I would like it to be towards the end, which I will explain in a second. So here are the scope changes, which was mainly work added to the sprint and adding their story point estimation. And if you look at the incomplete work items, you're going to see that there is a lot of incomplete work. And that is because Titus hasn't updated his stuff as of yet. So I don't know which of these are actually completed or not. And if you look at the completed work items, you will notice that all of the work that was assigned to me has been completed. And here's another look at the burn up and burn down charts for this sprint. As you can see, it does look a lot cleaner than the last sprint, but there is still more missing information. The remaining work still 16 and the completed work at 20. For the retrospective review, things that went well were the sharing results of progress. We did assign most of our tasks earlier in the sprint, which was something that we were trying to work on for this sprint. There was better coordination with the mechanical engineers and electrical teams, and we are nearly finished with the integration between my code and Abraham's code. The rooms for improvement are that we need to communicate clearer specifics for goals. Some of our goals are very vague. We need to integrate all of our code together, so not just me and Abraham, but also Titus. I believe our biggest issue is that we need to properly track task progress throughout the sprint and not wait till the very end to track our progress. Next, I will discuss the breakdown of labor, specifically the tasks and points that I was assigned. As you can see, all the tasks that were assigned to me were completed. So I was able to get the integrate obstacle outline, the LiDAR object detection logic, and a scaled distance system that is much more advanced than I originally anticipated. So all 13 of my story points were completed. And here is my updated Sprint 3 code. As you see here on the 8th line, there's a new import based on of what Abraham is using, so our stuff integrates better. On the to-do notes, I actually edited it so that it shows the amount of progress we've made with merging. So as you can see, as I was describing before, the merge with Abraham stuff, which he is doing, is nearly complete. So if I go down, this is probably going to be something I'm going to work on later if we have extra time, but we may also scrap this, so I'm not going to go over the obstacle bases. The point colliding obstacle index is supposed to be for the LiDAR sensing and kind of creating an obstacle. I added a color yellow for the LiDAR sensed obstacle color. The plan is to have the LiDAR sensors, or whatever sensors we use, kind of create a temporary barrier so it does not go forward during that time. This is a change to make the robot look like the physical robot design. If I go down way more, here's a method for computing the LiDAR local points, which is the 5 LiDAR lines that are in orange when I show the demonstration. And those lines, these are basically drawing the lines and making sure that they're offset correctly. And this is for the LiDAR occluded in safety zone method. So the sensors, which I'm calling LiDAR for now, I believe we're actually using something else, but I just didn't want to rename it, is going to be about 3 feet in length of sensing, and the safety zone is going to be at 6 inches. So if anything gets closer than 6 inches from the Roomba, it should stop the robot from moving forward. However, it would still be able to move either backwards or rotate left and right. It just will not be able to go towards the obstacle. And this is to return obstacle indices currently intersected. And I made sure it ignored boundaries because the boundaries that are getting drawn, I don't want that to be treated as the sensed obstacles. This is stuff that's been there for a while. This is to help with the scaling. So several of these drawing variables are going to have extra lines and extra variables inside of them to accommodate for the scaling. So this is the cleaner radius scaling with extra LiDAR. So the LiDAR feet and safety zone, which is 6 inches. We also are doing our best to make sure that it's relative based off of actual distances. So from what I got from the mechanical engineers is that while it is cleaning, the robot should be going a constant approximately 0.3 feet per second, which is going to be shown in the demonstration. Go down here. These are for the localhost UI readouts. But unlike the previous demonstration in Sprint 2, the readouts are going to be hidden on my screen, but it's going to be shown on Abraham's UI. And this is for the starting of the scaling mode to make sure it is able to scale separately from the cleaning mode. This is also for the stopping of the scaling mode, so when the scaling mode stops, it automatically goes into cleaning mode, which I will show in the demonstration. This is for the LiDAR sensor lines, so the length, especially for it to scale. And this is to prevent the LiDAR from going forward for when there's an obstacle that is sensed. Go down a little farther. This is so that it separates the movement and controls in cleaning mode versus drawing mode of the boundary. Way down here, this is for the cleaning mode boundary and scaling logic. It says ported from Simple Scaling, and Simple Scaling was a test file I created to make sure that the scaling was actually doable and didn't break everything. So I wanted a safer environment to do the scaling before I put into the main Pumbaa simulator. So back to this. This is for cleaning mode, making sure that the cleaning mode controls are different than the scaling mode controls. And this talks about the control lock. So, because we do not want the scaling to keep happening or accidentally go into scaling mode twice, we have it so scaling mode starts disabled, you start it, and you can only exit out of it once. So once you start it and you exit out of it, it automatically stays locked into cleaning mode and is unable to go back to scaling. And here are some of the app routes to help integrate it with Abraham's code. This is for the scaling parts. And that should be it for the code explanation. Now, if I actually run this, here we go. It starts much larger than before because it's going to zoom out when we go forward. So if I initiate the manual controls of scaling, which is the S key, you're going to see two scales. The one on top, which is a rough estimate of the 4 feet and 9 inches for the top boundary, and the left, which is a rough 3 feet 5 inches. So if I go forward, it actually zooms out and scales out, while also staying at a constant speed. This speed, once we get the information from the mechanical engineers, we'll be able to adjust the speed more. So I will have this at roughly 50 feet. And we can also create a boundary that is not just a square or a circle. We could also scale that way. Could go around. If I press S, you're going to see the lines for the LiDAR on up here, cleaner with the wheels. And if I actually move this around, it moves at the speed that we need it to. We can still activate the cleaning mode. They actually wanted it to reach out this far from the boundary, so I did change that. And we are able to actually move this much better. And once we get more of the sensors that we can actually test out, there should be yellow lines that are created that go in front of these LiDAR sensors that are temporary. And those should connect with one another to make a solid boundary that just cannot go forward once it gets to a certain distance. Which this was a lot harder than I thought, because in the simple scaling, because I didn't have all of this, all of the cleaning code, and I didn't have the shapes like in the simulator, it was hard to integrate both of them together, but I was able to do it, and we even are able to have the logic with the cleaning where it does not do the sliding that it usually does. And I will exit that. And for the next sprint, our main objective is going to be about integration. So we're going to try to integrate our stuff with each other. So Abraham's code with my code will be completed. And hopefully our code with Titus's code will be completed. And then we will try to integrate the actual sensors from the mechanical engineers into our combined code to help test some of the things that we are unable to test at the moment. And that is it for this sprint. Thank you, and I will see you next time.